Welcome to 11.8 expected value. So we're going to talk about what expected value is. So if something happens, if you keep doing the same event over and over and over again, what are we expected to get in the end? All right, so expected value is the mathematical way to use probabilities to determine what to expect in various situations over the long run. So that's kind of key there. In the long run, what's going to happen if we continue doing the same thing? So expected value is used to determine premiums on insurance policies, weigh the risks versus benefits of alternatives in business ventures, and indicate to a player of any game of chance what will happen of the game if played repeatedly. Okay? So we're going to compute the expected value. So in order to do that, the standard way to find expected value is to multiply each possible outcome by its probability. And then we add these products together. So for instance, if we look at this first example, we'll walk through it. Okay. So it is equally probable that a pointer will land on any one of four regions numbered 1 through 4. Find the expected value for where the pointer will stop. Okay, so I have an equal probability that it'll land on 1 through 4. So the probability of landing on any of those four numbers is going to be 1/4. So to find the probability or the expected value, we're simply going to take 1. If it lands on 1, what's the probability? 1/4. So this is our outcome. This is the probability, okay? And then we're going to add it to the outcome of 2 times its probability. So 1/4 is the probability of landing on a 2. Plus 3 times its probability. So 1/4, 1 out of 4 chances we land on a 3. Plus 4 times 1/4. So the probability of landing on a 4 is 1 out of 4. So then we just multiply these through, and we end up with 10 over 4 or 5 over 2. The other way we could write it is 2.5. So what does this mean? It means if the spinner is spun repeatedly, on average, it'll land on 2.5, or we'll get 2.5 per spin. So this is the long-term average. This is in the long run. What's the average number that we're going to get? This next example deals with a table of values. So let's suppose a fair coin is tossed 4 times in succession. We want to find the expected value for the number of heads. So let's take a look at this table here. So the number of heads, that is our outcome. Okay? And then our probability of each of those is in that column over here. So what we're going to do is we are going to take our outcome and multiply it by the probability of that outcome. And then we're going to add all of these together. So 0 times 1/6 plus 1 times 4/6 plus 2 times 6/6 plus 3 times 4/6 plus 4 times 1/6. Okay, that's how we're going to set up our expected value. So if we take a look over here, we've got that for us. So the probability of getting an outcome of 0 is 1/6, plus the outcome of getting 1 heads is 4/16, plus 2 heads at 6/16, plus 3 heads at 4/16, plus 4 heads at 1/16. And when we multiply and add those all together, we end up with 32 over 16, or simply 2. So if tossed repeatedly, the average of 2 heads per 4 tosses is what we would get. That's the long-term outcome. Let's look at this next example. An automobile insurance company has determined the probabilities for various claim amounts for drivers 16 through 21. That's you guys. Example 3 in the text uses the following probabilities. What if the claims of $0 and $10,000 were reversed? Thus, the probability of a $0 claim is 0.01, and the probability of a $10,000 claim is 0.70. Calculate the expected value and describe what this means in practical terms. So they want us to switch these two values, all right? So I want you to go ahead and set up your expected value equation. Go ahead and calculate the expected value and see if you can determine what it means in the long run. Check back when you get a chance to complete that problem. So by switching those values, the outcome of 0 has a probability of 0.01, plus the outcome of a $2,000 claim is 0.15, plus a $4,000 claim at 0.08, plus a $6,000 claim at 0.05, so on and so forth. When we calculate all of these, we end up with 8,000. So what does that mean? It means in the long run, the average cost of a claim is $8,000. That's if we change those values. That is really expensive. Hopefully that isn't actually the case. Now let's suppose we went back and we changed the probabilities back to 0.70 for a $0 claim and 0.01 for the $10,000 claim. If you were to go through and calculate the expected value, it would be $1,100, which makes a little bit more sense and isn't so drastic like the $8,000 that we came up with in that previous Part A example. But now, how much should the company charge as an average premium so it does not lose or gain money on its claim costs? Well, remember, insurance companies, they are a business, so they need to make sure that they're not losing money. So if the average claim in the long run costs them $1,100, the company at the very least should charge $1,100. In this way, it will not lose or gain money on its claim costs. However, again, since insurance companies are money makers, they will probably charge you more on their premium cost. Okay, so a lot of business decisions are interpreted in terms of dollars and cents. In these situations, expected value is calculated by multiplying the gain or loss for each possible outcome by its probability. The sum of these products is the expected value. So it's still the same concept, the outcome times the probability, and we add those all together. So let's take a look at a question involving the SAT. Okay. Now this kind of goes along with how the SAT used to be graded. So let's read through it. The SAT is a multiple choice test. Each question has 5 possible answers. The test taker must select one answer for each question or not answer the question. That was in the past. Now they say to answer the question, because in previous years, when you took the SAT, if you guessed and you got it wrong, it would deduct points from your score. Now it's not calculated that way. So anyways, let's move on. 1 point is awarded for each correct response, and 1/4 point is subtracted for each wrong answer. No points are added or subtracted for answers left blank. The table summarizes the information for the outcomes of the random guess on an SAT question. Find the expected value of a random guess. Is there anything to gain or lose on average by guessing? Let's explain. Okay, so again, here is our outcome. The gain or loss, that's our outcome again. Okay? And then we have our probabilities. So we take our outcome, multiply it by our probability. Okay? So 1 times 1/5, and then we're going to add that to the negative 1/4 times 4/5. So when we're going through and trying to calculate our expected value, the outcome of getting a correct answer is 1 out of 5, plus losing 1/4 of a point is 4 out of 5, because there's only 1 out of 5 correct answers, but there's 4 out of 5 incorrect answers. So that's where we get those probabilities from. So now when we go through and we calculate, we get an expected value of 0. So what does that mean? What's your interpretation? Pause the video and give it a thought. What you should have thought was, well, if my expected value is 0, there is nothing to gain nor lose by guessing. So in the end, you should guess. And either way, now that the SAT doesn't take points away for incorrect answers, you might as well guess if you don't know the correct answer. Now we'll get into expected value dealing with average payoff or loss in a game of chance. So we're going to calculate it the same way. Expected value can be interpreted as the average payoff in a contest or game when either is played a large number of times. So remember, expected value deals with the long run. So to find the expected value of a game, multiply the gain or loss for each possible outcome by its probability, then add the products. This is what we've been doing all along. It's just a different type of example. Okay, so let's look at this checkpoint 5. A charity is holding a raffle and sells 1,000 raffle tickets for $2 each. One of the tickets will be selected to win a grand prize of $1,000. 2 other tickets will be selected to win consolation prizes of $50 each. Fill in the missing column in the table. Then find the expected value if you buy 1 raffle ticket. Describe what this means. Then, what can you expect to happen if you purchase 5 tickets? So let's just talk about the 1 ticket, okay? So we know that there are 1,000 raffle tickets, okay? And they cost $2 each. One of the tickets will be selected to win the grand prize. So that's where we get the probability of winning the grand prize is 1 out of 1,000, okay? 2 other tickets will be selected to win consolation prizes of $50. So 2 out of the 1,000 are going to win the consolation prize. So that leaves 997 out of 1,000 as losing tickets. Okay, so let's talk about the gain or the loss. Now keep in mind, you spent $2 on this ticket. So if you win the grand prize, how much did you actually gain? So I take 1,000 and I subtract $2. So I'm actually gaining $998. Okay? Now, if I win the consolation, I still paid $2 for my ticket. The consolation prize is $50, but how much money did I gain? Hopefully you're able to say you gained $48. Okay, because you get that $50 back, but 2 of it is what you paid to play. So what if you win nothing? Well, if I don't win anything, I lose $2. Okay, so now let's go ahead and set up the expected value for buying 1 ticket. Okay, so the expected value, if I win the grand prize, I win $998, and that's a likelihood of 1 out of 1,000. Plus, if I get the consolation prize, that's a likelihood of 2 out of 1,000. Plus, oh, here's my loss. If I don't win, I lose $2, and the likelihood is 997 out of 1,000. When we multiply and add those together, we end up with negative 0.90. So what does this mean? It means in the long run, we should expect to lose 90 cents. Okay? Now what I want you to do is I want you to fill out this column if you were to buy 5 tickets. So think about what 5 tickets cost you at $2 each. If you win the grand prize, how much are you gaining? If you win the consolation prize, how much are you gaining? If you don't win, how much are you losing? Pause the video, fill out that column and check back. Okay, did you fill it out correctly? If you win the grand prize, you're really up $990 because you paid $10 for 5 tickets. If you win consolation, you really won $40 because you paid $10 for the ticket. If you don't win, you're losing $10. Now I want you to go ahead and set up the expected value and tell me what it means in the long run. So I got negative 8.9 for the expected value of buying 5 tickets. So take a look at my setup. Double check that that's what you get. And then what's our interpretation? Since it's negative, it means I lose $8.90 in the long run if I buy 5 tickets each time. This last example, I want you to try it on your own. In the game of One Spot Kino, a card is purchased for $1. It allows a player to choose one number from 1 to 80. A dealer then chooses 20 numbers at random. If the player's number is among those chosen, the player is paid $3.20, but does not get to keep the dollar paid to play the game. Find the expected value of a $1 bet. Describe what this means. So first, before you can do that, I want you to try to give this table a try. All right? The outcome of your number being called, what's the gain or loss, and what's the probability of that happening. Okay? The outcome of your number not being called, what's your gain or loss, and then what's the probability of that happening. Give it a try, then check back. Okay, were you able to fill that out? So, if my number is called, I get $2.20. Remember, I get $3.20, but they keep my dollar. So I really only gain $2.20. If my number isn't called, I lose my dollar bet. Now, remember, the dealer chooses 20 numbers. So I have a 20 out of 80 chance that my number will be called. So that's a 1/4 probability. My number of not being called is the other 60 out of 80 numbers, or 3/4 probability. All right, utilize this. Now go ahead and set up your expected value and tell me what it means in the long run. Okay, I got -0.20. So after you set everything up, double check it, multiply through. So what does this mean? In the end, in the long run, if I keep playing one spot Kino, I'm going to be expected to lose 20 cents. Not too bad, but still not in my favor. All right, if you have any questions on this video, let me know and we'll talk in class.